going to do part 2 of this video. Eventually, I'm going to get to answers that can't be included in my solution. For 16, two of the denominators are already identical at x plus 3. That's a good place. The 1 that was in the problem wasn't a fraction, so I made it a fraction. And I can turn a fraction that has a 1 in the denominator to have any denominator. So I'm going to multiply that denominator, or the 1 over 1, by x plus 3 over x plus 3. That's going to give me 2x over x plus 3 equals, I don't really need 1 times x plus 3 because 1 times anything is itself. So for that 1 times x plus 3 over 1 times x plus 3, I'm just going to write it as x plus 3 over x plus 3. And then the other fractions I'm not changing. So I made my common denominators. Now I'm going to clear my fractions by multiplying through by x plus 3. So cancel, cancel, cancel. That's going to give me 2x equals, I'll emphasize, 1x plus 3 minus 6. Combine like terms on the left-hand side. This is going to give me 2x equals 1x, and 3 minus 6 is minus 3. If there was a square, I'd set it equal to 0 and solve by factoring. Since there's not a square, I'm going to subtract to get the x's on one side, and I'd solve by dividing, but it turns out I won't even have to divide. This is going to give me x equal to negative 3. I'm going to go to check. And finally, I'm getting to the problem that needs to happen. I'm going to go to this problem, the original problem, and change the x's to negative 3. So I'm going to go 2 times negative 3 over negative 3 plus 3, and see if that equals 1 minus 6 over negative 3 plus 3. This is the bad thing that can happen. I could do perfect algebra, and I'm going to get an undefined when I'm checking. And if I get an undefined when I'm checking, which I'm going to get there, I say the solution needs to be thrown out, because this side right here comes out to be 6 over 0 without my calculator with undefined. If the algebra for checking gives you an undefined, then that number can't be included in the solution. Or if you include it in the solution, you need to say it doesn't check. So the only answer that came up for this doesn't work, so there's no solution to this problem. So the answer can be written two ways. There's no number that can make the left side of the equation equal to the right side of the equation. So I'm either going to write no solution, and that's probably the best answer, because there is no number I can plug in to make the left-hand side and the right-hand sides match up. Or for an answer, I can say x equal to negative 3 does not check, because it's not an answer that checks. The fancy word that we can use in place of does not check would be the words is extraneous. So that would maybe even be a third or. We can say x equal to negative 3 just to show that you found the algebra correctly. So any one of these is okay, but this really doesn't have an answer. There's no answer I can plug into the original problem to make both sides come out to the same when you get an undefined when you're checking. Usually I'd say no solution if the only solution that comes up gets thrown out, but you can use these other choices as well. Oh, let's do 17 together. In 17, I'm going to factor this denominator. The x squared minus 9 is a square with a minus. So I'm going to divide the exponent by 2 and square root the number. I'm going to get 2 parentheses for that x squared minus 9, one x plus 3 and the other x minus 3. When we have a denominator already and I factor, I write the common denominator first. So I'm going to get my factoring done so I can figure out the common denominator. This x minus 3 I'm going to put in a parentheses. And to the right of the equal sign, I'm going to write x minus 3 first, because that's the denominator that I already see, times x plus 3. I'm going to make my denominators the same by multiplying the left fraction by x plus 3 over x plus 3. So now I have 5 times x plus 3 over x minus 3 times x plus 3 equals 2x over x minus 3 times x plus 3. Have the same denominator, so now I can clear the fractions. I'm going to write the common denominator just outside of big parentheses. It fits better here on the right hand side. Cancel my fractions. Now I'm left with 5 times x plus 3 equals 2x. There's no square, so I'm not going to set it equal to 0. I'm going to clear my parentheses. I'm going to go 5 times x, which is 5x, 5 times 3, which is 15. I'm going to get the letters on one side by minusing 5x from both sides. This is going to give me 15 equals negative 3x. I'm going to divide both sides by negative 3 and get negative 5 equal to x, which is likely an answer unless I get undefined when I plug it in. So in 18, the original problem is 3, whoops, we're doing 17. In 17, the original problem is 5 over x minus 3 equals 2x over x squared minus 9. I'm going to change every x to negative 5. So I'm going to go 5 over negative 5 plus 3 minus 3. On the left-hand side, the negative 5 doesn't need to be in a parentheses because that x doesn't have a coefficient or an exponent. But on the right-hand side, both of my x's, when I change them to negative 5, will go in a parentheses. So on the right-hand side, in the numerator, I get 2 times negative 5. In the denominator, I get negative 5 in parentheses squared minus 9. So I'll simplify both sides. Left-hand side, 5 over 5 minus 3. That's not undefined because it doesn't give me a 0 in the denominator. So this answer should check if I didn't make a math error. Right-hand side, 2 times negative 5 over parentheses negative 5 squared minus 9. And I'm worried here. That says negative 5/8. Let me double check first that I entered this right. So the initial problem, 5 multiplied by x plus 3, that's 5x plus 15, that feels good, minus, my answer looks right. Maybe I made a mistake checking. Let me recheck, maybe I made some sort of mistake. Left-hand side is supposed to be fraction, 5 over negative 5 minus 3. Maybe I just didn't read it. This is good. This is negative 5/8 equals negative 5/8. I probably just made a calculator error. So I'm good. That answers x equal to negative 5 for 17. Let's do 19 together because I think 19 has 2 solutions. One checks and one doesn't, and just want to show you what to do when that happens. And there aren't any problems on the test where if you do perfect algebra, you get a solution that doesn't check. So this is, a semi-important skill. This skill comes up again later in the semester, but for now it's not the most important. I'm going to factor this denominator first in problem 19 that I'm attempting. And to factor this denominator, I need numbers that multiply to 8, positive 8, and add to negative 6. And this is going to be negative 2 and negative 4. This is the double negative. I didn't pull my template out here. But negative 2 times negative 4 is positive 8. And negative 2 plus negative 4 is negative 6. I'm going to sight factor that denominator. It's going to factor into x minus 2 times x minus 4. And there's no real choice to what to plug in first, what to write first, because both denominators occur on the other side. Let me just do the x minus, I'll do the x minus 2 first. I'm going to put all my denominators in parentheses because they're going to need to be for the next step in parentheses. I guess I'm going to write the x minus 2 first. So I factored my denominators. Now I'm going to make all the denominators the same. The factors I need both an x minus 2 and an x minus 4. The left fraction has the x minus 2. It doesn't have an x minus 4. So top and bottom, I gave it an x minus 4. So now the first fraction and the last fraction, look, they have the same denominator. The middle fraction is missing the x minus 2, and I got to give it top and bottom. So now I've made this. I've made x times x minus 4 over x minus 2 times x minus 4 plus 1 times x minus 2, I don't really need the 1, over x minus 2 times x minus 4 equals 2 over x minus 2 times x minus 4. I've made all the denominators the same, so I can clear the fractions by making a giant parentheses around the whole problem, and I'll multiply by that denominator. Clear, clear, clear the fractions. This is going to leave me with x times x minus 4. I'm not going to write the 1. I'm just going to write plus x minus 2 equals to 2. Fractions are gone. I'm going to clear this parentheses by going x times x, which is x squared, x times minus 4, which is minus 4x. I still have the plus x, which I write as plus 1x. Still have the minus 2. I still have the equal 2. Because there's a square, I'm going to solve it by setting it equal to 0, and I'm going to factor. I'm going to combine those x's before I do that. Minus 4x plus 1x is negative 3x. Now I'm going to set it equal to 0 and get x squared minus 3x minus 4 equals to 0. I'm going to sight factor. My numbers here need to multiply to negative 4 and add that really is a subtract to negative 3. And that's going to be 1 and negative 4, because 1 times negative 4 is negative 4. 1 plus negative 4 is really 1 minus 4, which is negative 3. So my sight factoring gives me an x plus 1 and an x minus 4. That's okay. This is good. One of the solutions is x equal to negative 1. The other solution that my algebra gives me is x equal to 4. I need to go to the original problem and check each. First, I'm going to check the negative 1 by going as negative 1 over negative 1 minus 2 plus 1 over negative 1 minus 4. Does that equal 2 over negative 1 squared minus 6 times negative 1 plus 8? Let me check. Left-hand side, fraction negative 1 over negative 1 minus 2. Get out of the denominator, plus fraction 1 over negative 1 minus 4. Left-hand side comes out to 2 over 15. On the right-hand side, I need to use some parentheses. Right-hand side is fraction 2 over parentheses negative 1 squared minus 6 times negative 1 plus 8. And that gives me 2 over 15 again. So x equal to negative 1 is an answer. There is a number that I can plug in to make both sides the same. This problem isn't a no solution. It actually has a solution. Next, I'm going to try to check x equal to 4. When I do the same thing, I'm going to go is 4 over 4 minus 2 plus 1 over 4 minus 4. Does that equal 2 over 4 squared minus 6 times 4 plus 8? I can already see an issue right here. This fraction in the middle is going to cause my calculator to blow up because it's going to be undefined. And the second I get undefined in my checking, I say that the answer is extraneous and it shouldn't be included in the solution. So in this problem, I got two answers. One of the answers checks. The other answer I get an error, so it doesn't check. So realistically, when I go to write my answer, I shouldn't include this 4 without writing some words saying it doesn't check. So negative 1, it checks because when you plug it in, both sides come out to be the same number. So for an answer, I could either just say x equal to negative 1 and make no comment about the 4, or I can say x equal to -1 is a solution. X equal to 4 is not a solution. Or I could say is extraneous, which is the mathematically sophisticated term for it doesn't check, but the algebra produced it. Both of those would be okay, but you don't have to include a solution that doesn't check. All right, one more hardish problem, and then we get to the easy part. The last 10 problems are super easy. So for problem 22, let me do it on another sheet of paper. In fact, let's do 21 together to make sure we're all good with this. So I'm going to write 21 down for you. Maybe pause the video and give it a go. See if you can do it. And then check with my work. So what I'm going to do is throw some parentheses around the denominators. I need to have all the denominators have the same variables. There's no factoring here, so that far right denominator in 21, I need to give it the x minus 3 numerator and denominator. So now I have the same variable structure for all the fractions. I need to get 2's in front of my parentheses when I don't have a 2. So the first two fractions I'm going to multiply by 2 over 2. So this is going to give me 6 over 2 times x minus 3 equals 2x over 2 times x minus 3 minus 3 times x minus 3 over 2 times x minus 3. So I've made each fraction have the same denominator. Since there's an equal sign, I'm allowed to clear the fractions. In section 2.4, we couldn't clear the fractions because there wasn't an equal sign. So clear the fractions. This gives me 6 equals 2x minus 3 times x minus 3. I don't see a square, so I'm not going to set it equal to 0 and solve by factoring. I'm going to clean up that right-hand side. I'll clear the parentheses and go minus 3 times x is minus 3x. Minus 3 times 3 is plus 9. Combine the 2x minus 3x and 2 minus 3 is negative 1. Set it equal to 0, or get the numbers and letters on opposite sides by minusing 9. I get 6 minus 9 is negative 3 on the left-hand side. Have the negative 1x on the right-hand side. Divide by negative 1, divide by negative 1. My algebra only gives me one answer, so the answer is either going to be x equal to 3, or if that doesn't check, there's going to be no solution because I'm throwing out the only solution my algebra gave me. I'm going to check in the original problem, which is 3 over x minus 3 equals x over x minus 3 minus 3 halves, and I won't even need to use my calculator because immediately as I try to check, I can see that I'm going to get a 0 in a denominator. This denominator right here is going to be a 0, and that's going to be undefined. If I did this on my calculator, I'd get some sort of math error. That means this solution shouldn't be included in my answer, or I should say it's not a solution. So for my answer, because the only solution that the algebra generated doesn't check, I could just say no solution. That's the best answer. I don't need to write answers that don't check. Or I can say x equal to 3 is not a solution. There's actually no number I can plug in and make both sides come out to the same number. Both are k. Or I could even get more sophisticated and say x equals 3 is extraneous. That's just a more elegant way to say it's not a solution. The rest of the problems are buried at the end of this section because the algebra that we use for them is the algebra that we need for 2-6, which is another section of word problems. So each of the problems between 23 and 30 are proportions. They're one fraction equal to another fraction. These I can solve by cross multiplying. And these I don't technically have to check, but I'm going to check. So all the problems on the end, they're equal signs and they have fractions, but the nice thing is there's only one fraction on either side of the equal sign. There isn't an addition or subtraction on either side of the equal sign, and when that happens, you can cross multiply. So let me cross multiply up and get x times 28, which is 28x, down 2 times 7 is 14. I'm going to divide by 28. On the left-hand side, I'm left with my x. Now on the right-hand side, I can reduce that fraction. It turns out that cross-multiplying doesn't generate solutions that don't check unless you make a math error. But let me check just to show you that it does check. So I need both sides to come out to be the same number. And on the left-hand side, if I'm checking it, those 3 layered fractions are challenging for me. So let me do the left-hand side with 2 divided by 1/2. The left-hand side comes out to be 4. And the right-hand side, I know that 28 over 7 is 4. I don't really need a calculator for that. The answer is going to check. For these cross-multiplying problems, you really don't have to check, but you can to make sure you don't make a math error, but you won't get solutions that don't check. For 26, cross-multiply. Cross-multiply, I like my x's on the left-hand side if only one side has an x. So I'm going to get 5x equals 7 times 10, which is 70. Divide by 5, divide by 5, and get x equals, I think, 14. Yeah. And I'll check it. Maybe I'll stop checking because I really don't have to. But is 7 over 5 equal to 14 over 10? I need to simplify this side, make sure it's that side. I could do that without my calculator. But 14 over 10 reduces to 7/5. This gives me 7/5 equals 7/5. Cross-multiplying won't generate solutions that don't check, so you don't really have to check these problems. 28, cross-multiply down, cross-multiply up. Cross-multiplying down, I get 12 times x minus 2. Cross-multiplying up, I get 4x times 2. 12 times x minus 2 is 12x minus 24. 4x times 2 is 8x. I need to set it equal to, need to get the numbers on one side, the letters on the other. It's easier for me to get the letters on the right-hand side, so I don't have to do double moving. Cancel the 12x's on the left-hand side. On the right-hand side, 8x minus 12x is negative 4x. And then divide by negative 4, divide by negative 4, and I'll get 6 equals to x. I won't check it just to save a second, but it will check unless I made a math error. Oh, let me just check it. See if 6 minus 2 over 4 times 6 equals 2 over 12. So left-hand side, fraction 6 minus 2 over 4 times 6. Left-hand side reduces to 1/6. The right-hand side, 2 over 12, reduces to 1/6 as well, so I'm good. I don't really have to check these. Last one, and the section's done. Cross multiply and do 3 times 2x minus 3 on one side, doesn't matter which side. Cross multiply and do 5 times x on the other side. Your sides can be flip-flopped. The 3 times 2x minus 3, I go 3 times 2x, which is 6x. 3 times minus 3, which is minus 9. I don't see a square, so I shouldn't set it equal to 0. I need to get the letters and numbers on opposite sides. I'm going to minus 6x from both sides, which will give me minus 9 equals minus 1x, and then divide by negative 1, divide by negative 1. Left-hand side comes out to be 9. The right-hand side gives me the answer of x. That will also check. What the heck? Let me do the left-hand side. 5 divided by 2 times 9 minus 3. If I plug in 9 on the left-hand side, I get 1/3. Now I'm going to plug 9 on the right-hand side. If I plug 9 on the right-hand side, I get 1/3. So I've checked everything, which is never a bad idea. All right, so just one section left in the chapter. It's a section on word problems, and then we do the practice test. So we'll just stop the video.